Hello, we want to talk to you about our project, creating a habitat for healing at Banksia Gardens, and habitat stands for heat and biodiversity tracking through automated technologies. I am Lily Bromberger,
I'm Stephen Fanning.
I'm Eric Shimon.
And I'm Emmanuel Vargas.
and before we get started, we want to do a acknowledgement of country. This is just how we pay our respects to elders past, present, and future of all the native populations, both throughout Australia and throughout Massachusetts and the entire United States.
The biggest problems affecting Australia today are extreme heat in which temperatures reach over 102 degrees Fahrenheit. Biodiversity is lost, such as seen in the 2019-2020 summer fires that killed 3 billion animals, as well as economic inequalities. For example, in the housing crisis where people wait more than 10 years for government subsidized housing.
These problems are especially prevalent in Broadmeadows, which is a disadvantaged suburb located northwest of Melbourne, and it's up to community service organizations like our sponsor to try to solve some of these issues. Our sponsor is Banksia Gardens Community Services, and they're a community service organization that looks to improve the lives of Broadmeadows residents through a variety of means. And this is usually through things like providing food, tutoring, and after school programs. But recently, they've also started trying to improve the environmental sustainability of the region.
This is through their climate adaptation garden project, which consists of heat havens, which provides a space for cooling for residents, the community gardens, which is an area to grow food to supplement the existing food pantry, and as well a food forest, which is a combination of the heat haven and community gardens, where trees are planted to provide natural shade and vegetation. However, it is important for Banksia to evaluate the success of the climate adaptation gardens project, but we first must define what success is. And this is through lowering surface temperatures to combat the effects of heat waves, increasing biodiversity to challenge the effects of climate-induced biodiversity loss, as well as prolonged community engagement to improve the well-being of Broadmeadows residents.
So, it is our goal to evaluate the success of the Climate Adaptation Gardens project, and in order to do that, we needed to come up with a method of evaluating whether these three things are happening. So, let's start with lower surface temperatures. In order to see whether temperatures are lowering throughout the gardens, we designed and implemented a network of automated temperature sensors to be placed throughout the gardens in specific locations. Specifically, each sensor needed to be able to connect to Wi-Fi, take temperature readings, upload those temperature readings to an external database, and then go to sleep until it needs to take another reading, all while consuming relatively little power and at a low cost. So, in order to come up with this design, we went through three major steps. The first of which was coming up with an initial design and collaborating with our sponsor to talk about things like feasibility and budget. We then went through 3 rounds of prototyping and using the results of each stage to change and modify our design for the next. Then, once we had our final sensor design, we went through multiple rounds of testing as well, just to verify that the hardware was working together in the way that we wanted to, and that the software was all running smoothly. So, this is our final sensor design. It's all centered around the Raspberry Pi Pico W, which is a single board computer that controls when and how the sensor takes its readings. We also use the Adafruit DHD20 to take these readings and 2 rechargeable D batteries to power it all. These batteries should provide enough charge for the sensors to operate for over 5 months between recharging.
So with temperature covered, we will next go into the method we created to track biodiversity, which utilizes citizen science or public participation in the data collection. We employed an app called iNaturalist, through which users can upload a picture of the specimen to the app and let an artificial intelligence state what that is. Once we had this data, we needed to make some meaning from it. So iNaturalist records a ton of data about each observation, which can be extracted using a coding language called Python. From here, we're able to filter and manipulate the data, to serve Banksia Gardens' needs and then send it to a database that Banksia Gardens could control and create visualizations from. In the filtering stage, we removed redundant data, which is labeled in red, and kept the data that would be helpful for analysis, as shown in green. We also found some columns that were not directly helpful, but could be manipulated to be more useful. One such column would be the coordinates of where a picture was taken. The coordinates themselves do not really mean much, but we were able to map them to specific locations in the gardens using a geographical software called QGIS. This enabled us to create these nice visualizations that Banksia Gardens can use to compare where there are more organisms throughout their gardens. Lastly, the process of getting the data from iNaturalist to Google Sheets is automated using Banksia Gardens' personal Linux server, so new data that is collected over the next 10 to 20 years can be uploaded to the database without someone manually running our code.
All right, the last thing we have in this project is bringing together the community engagement aspect with ensuring that we get constant data collection of the biodiversity. we have identified 3 areas where we want to implement community citizen science activities, and that's at the after-school activities they host on a daily basis, at the community days, which are hosted on the weekly to monthly basis with adults who live in the Banksia Gardens housing estate next door, and lastly with bio blitzes, which is a 24-hour plus community engaged citizen science biodiversity collecting activity. This is going to be hosted by the city of Hume, but they want to collaborate with Banksia Gardens and use it as a host for this activity this year. These activities have very different requirements, skill levels, and time limits. And because of this, we have created a resource that combines activities with additional places to look to help plan these. And that is the first of our 6 deliverables. In addition to that, we also have created and installed a network of heat sensors, created a database that's automatically uploading, produced 2 manuals, one for heat sensors, one for biodiversities, the biodiversity aspects, which will help Banksia Gardens and other organizations recreate and maintain these systems. In addition to that, there are supplementary YouTube videos to help show that process, not just explain it in words. And lastly, we centralized all of this into our website where Banksia Gardens employees can look here for anything they might need, use this to share with other organizations about what we did. And in addition to that, it contains our open source code that we created to ease the replication of this. So anyone who looks at that can implement this easily in different places outside of Banksia Gardens. Our project has a few main impacts. The first of which being we are satisfying 2 of the United Nations Sustainable Development Goals, the first of which being addressing inequality by creating spaces of shade for people who are unable to escape extreme heat. And additionally, the climate adaptation goal, where we are creating an environment that is actively trying to survive the climate change impacts instead of dying off, and we're creating an area for plants and animals to thrive. Additionally, our project helps reduce the work done by Banksia Gardens employees because now they can do other things while our automatic system can collect information about heat and hopefully biodiversity once people are aware of the system and help them evaluate the success of their climate adaptation gardens. And lastly, this has a long-term goal of creating a community who cares about the environment and will do things to help protect it for the rest of their lives. Thank you for learning about our project.